Okay, so we are going to now talk about changing the period for some of our graphs, and what would that look like in the equation, and what does that look like for the actual graph. So first of all, let's talk about what periodic functions are. They're just functions that are going to repeat their values in the same order every certain amount of units. So for sine and cosine, they are considered periodic functions since they repeat their values in the same order after 2 pi radians. So we say that their period is 2 pi. So when you look at the equation, we're going to use capital B multiplied to x, which is the variable that represents the angle, the radians, right? To signify the parameter that's changing here. So if b is 0, then nothing interesting is happening, so we're going to, put that as a restriction. And then if b is equal to 1, then we have our standard sine and cosine where our period is just 2 pi. So really we're looking at when the absolute value of b is not equal to 1, and that is going to give us a period change. So we're going to use this formula, the 2 pi divided by the absolute value of b, in order to calculate out our new period. So let's take a look at an example here. It says find the period of y equals cosine of 2/3 x. So this 2/3 is our b. We're going to plug that into our formula, 2 pi over 2/3, which works out to be 3 pi. So our period is 3 pi. So there's two ways that you can think about this. The first way is to think about your cosine will complete one full cycle or one complete rotation around the unit circle after 3 pi radians. Or at 2 pi radians, you're only going to have completed 2/3 of your curve. So this will be a little bit more clear when we see an actual physical example of a graph that's period has been changed. So let's take a look at that. So we'll start off pretty easy here. Y equals the cosine of 3x. To figure out our new period, we take 2 pi and divide it by 3. 2 pi over 3 is going to be where cosine completes its first cycle of its graph. So we're going to place this somewhere pretty early on over here since we have to go all the way out to 2 pi. We're going to need some room for that. So I'm going to put 2 pi over 3 right here. Once we have established this ending point for one complete cycle, we're going to cut up this space between 0 and that point into 4 equal parts. So half of 2 pi over 3 is pi over 3. Then half of this space is pi over 6. And then we need half of this space again. Either take the average of these two, or you can now see that we are counting by pi over 6 radians. So each tick mark is considered pi over 6 radians. So there's 1 pi over 6, 2 pi over 6, here's 3 pi over 6, which happens to reduce to pi over 2, and then this is 4 pi over 6. So once we have these 4 markers, we can now go in and start placing our points where they belong for cosine. We know that cosine starts up here at 1, goes down to 0, down to -1, back up to 0, and then back up to +1. Okay, and I can actually draw this in the best I can with the computer here. Okay, so we get our cosine. Ooh, that was a little off. Okay, so there's our cosine curve, to the best of my ability. All right, so what we now have to do, once we have our first cycle of cosine, we have to keep repeating this pattern all the way out to 2 pi. So let's think about this. If we go every 2 markers and then the third one is a pi over 2, our typical way of breaking up a nice normal y equals cosine x curve would go out to 2 pi using pi over 2 as the first marker. So we want to start figuring out where the pi and 3 pi over 2 and 2 pi are going to be based off of these little tiny increments. So it looks like every third marker is one of ours. So starting from here, we go 1, 2, and then here's the third one should be pi. And then 1, 2, 3, that should be 3 pi over 2, and then 1, 2, 3, and that should be 2 pi. And you can think about this if you counted 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. So you get there that way if you don't want to have to count. And notice that I don't need to actually write in all these values. You only need to write them in for the first cycle, okay? But then we do need to have these increments to kind of tell us how far we're going in, kind of little markers there. Okay, so then we're just going to continue on with our pattern, knowing that we started up here at 1. We go down to 0, -1, 0, 1, 0, -1, 0, and then back up to 1. Let's see if I can draw this in fairly quickly. Oops. Okay, there we go. Yeah, that's not too bad. All right, so remember how I said there's two different ways you can think about this. One way would be to say that at 2 pi over 3, right here, you have completed one complete cycle of cosine, which is our typical way that cosine looks. Or you can look at this number, 3, and it tells you how many cycles, or fractions of a cycle, you will have completed by the time you get to 2 pi. Well, look at this. Here's 1. There's 1 cycle. Here's 2 cycles. And here's 3 cycles. So there's 1, 2, 3 cycles of cosine by the time you got to 2 pi. Okay, so there's one example. We have another example that we're going to take a look at. Get rid of that. Okay. Now we have y equals the sine of 1/3 x, and this time we're going all the way out to 4 pi. Okay, well, let's take a look at what our new period is going to be. 2 pi divided by 1/3 gives us 6 pi. So that's really big. We're used to going only as far as 2 pi. Now we have to go all the way out to 6 pi to get one complete cycle done. Okay, so what we're going to do all the way out here, we're going to place a 6 pi. Half of that is going to be 3 pi. Half of that again is 3 pi over 2. And then somewhere halfway between here is 9 pi over 2. You can either average these out, or you can realize that we're now counting by 3 pi over 2. You can get there that way. Okay, so let's see here. Sine starts at 0, goes up to 1 at the first marker, down to 0, then down to -1, and then back up to 0. So if I were to connect this, it's much better when it's bigger. Okay, so how are we going to think about this? Well, at 6 pi, we have completed an entire cycle. Okay, so at 2 pi, we'll have only completed 1/3 of the cycle. Well, we don't know where 2 pi is on here. So what we can think about is maybe we just start marking off pi increments, because here's 3 pi, so this distance needs to get broken up into thirds. So there could be pi and 2 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. What just happened? Oh, well, okay. There's 5 pi should be over here. I don't think I put it on there since we only had to go out to 4 pi. Okay, so what we're going to do here is at 2 pi, right here, you can see that only 1/3 of the cycle has been completed. But we need to go all the way out to 4 pi. So how are we going to do this? So you can graph this just like we did here, and then I'll get rid of this. And then if you wanted to, you can just take a highlighter and highlight as far as we needed to go, which means that we stop right here, and say that this is just the graph that we need. Or you could erase this part if you wanted to. You can do whatever you want. But I need to know that 4 pi, this number right here, that's as far as you needed to go. Okay, so you cut it off somehow, either highlight it or erase it or something. Put a marker there. Okay, now there is one last example that I do need to go over with you. And that is these type of problems where they're asking you to come up with the equation based off of a given amplitude and period. So they say find y equals a cosine bx. So remember, a is the parameter for amplitude, b is the parameter for period. So first of all, remember that the absolute value of a is equal to 1/2. That means a could potentially be a plus or minus 1/2. Okay, for the period, this one's a little bit more complicated because there is a formula that we have to follow. So remember the 2 pi over the absolute value of b is equal to your period, which is 3 pi. So we go through there and do the math and figure out that b is actually plus or minus 2/3. So because we have the plus or minus for both of these, that means we're going to have more than one answer because we have to come up with all the combinations of these numbers together. So the first one would be when they're both positive. Next one would be, say, when we make the a negative, but we keep b positive. Third option would be if a is positive and b is negative. And then the last option would be if they're both negative. And notice that I had to put parentheses around this because we are taking a negative and we don't want it to look like we're taking cosine and subtracting the 2/3 x. It's the cosine of this entire angle. And no, we are not going to take away the minus sign dealing with odd and even functions. We're not going to deal with that. We want to see it exactly in this form with the plus or minuses. And no, you're not going to just write plus or minus 1/2 and plus or minus 2/3 and write only one equation. You need to have 4 answers. Okay, so that's it. Don't forget 4 answers when you come to these problems. Okay, sorry that that was so long, but it's hard, I know.